Hey, hello students, welcome to the second lecture of permutation combination. As you know, in the last session, we understand what we call principle of counting. Now we'll understand how we can use principle of counting to find different number of arrangement. So what is permutation? The meaning of the permutation is the its permutation meaning of permutation is arrangement. Suppose we are finding like different arrangements. Suppose two people are standing in a queue. Suppose A and B is standing in a queue. So first in the first position we have A, in the second position we have B. So this is one arrangement. If you change another arrangement, can be first in the first position, like we can put B, and in the second position we can put A. These are the arrangements. So permutation is nothing but arrangement. So what is a like suppose someone is asking like to find you number of arrangement, so we'll call it it's a permutation problem. It's a permutation problem. We have to count number of arrangements. So how we can count with the help of principle of counting, we'll see here. So let me give you first one example here. So what is basically permutation? So first, so what is permutation? One important as you already know, one important application of fundamental counting principle or principle of counting is determining the number of ways that n element can be arranged. So one of basically in permutation we find the number of way we can arrange in different like type of elements. How we can find number of arrangement of n different object. So with the help of fundamental like with the help of principle of counting, we can easily find the arrangement total number of, we can easily count the total number of arrangement. We'll see with some examples here. So and what is the definition of like permutation? And one more thing, in permutation whenever we are talking about arrangement, the order is very much important. Suppose we change the order, A B, suppose we are like two people is standing in a queue, A and B. AB is a one arrangement, and if I change the order, if I change the order like BA, B will be another arrangement. So in permutation, obviously order is necessary, because if I change the order, there will be a different arrangement, there will be a different permutation. So here, what is the definition of permutation? As you can see, a permutation is an arrangement of definite order. So permutation is an arrangement of definite order. There will be a specific order. Permutation is an arrangement in definite order of a number of objects taken some or all at a time. You can take few numbers from like or you can take every numbers, all the numbers, and you can count the arrangement. So we can find the arrangement. So in permutation problem, how we can solve? Let's take one example here. So we have one example, finding the number of permutation of n elements. So here, how many permutation or how many arrangements? So permutation is nothing but arrangements. How many permutation of the following letters are possible? We have 5 letters here. No, sorry, we have 6 letters here from A, B, C, D, E, F. Now, how many ways we can arrange this like 6 letters? Like if I talk about arrangement, what is the meaning of arrangement? How many ways I can arrange these 6 letters? Either like this arrangement can be something like this: A, C, B, D, E, F. This is one type of arrangement, or this is, we can say, B, C, A, D, E, F. This type of arrangements are there. So how many total number of arrangements will be there? We have to count. So that is the question here. Now think about it, how we can use principle of counting. Here my event is we have to find how many possible permutation, means how many possible arrangements are there, how many possible permutation of the following letters are possible, how many possible arrangements are there, like how many possible arrangement we can make with these 6 letters. Think about it to find that. So first, like there will be like we can think to in this way. First, consider the following reasoning. First position, so we have 6 position, right? We have to like, if we have to arrange 6 letters, there will be 6 position, right? 1, 2, 3, 4, 5, and 6 position like this. Now we have 6 letters. Now consider the following reason. First position, suppose if I consider this is the first position. So how many like letters we can put here? Either I can put in the like in this any arrangement, any, if I talk about any arrangement, in any arrangement, either I can put A or B or C or D or E or F. 6 letters I can put in the first position, right? 6 letter I can put in the first position. So for the first position, any of the 6. So consider the following is, for the first position I can place any of these 6 letters, right? Now in the second position, how many letters I can put? After putting one letter in the first position, one letter in the first position, either I can put A, B, C, D, E, or F. Then after putting one letter in the first position, then there will be 5 more, like there will be remaining 5 I can put in the second position. Any of the remaining 5 letters I can put in the second position here. So 6 for these, 6 possible way I can put one letter over here, and after that 5 possible way I can put a number here. With the same reasoning, how many letters will be there to put in the third position? How many letters will be there to put in the third position? Obviously any of the remaining 4 letters. After putting one letter in the second position, then in the third I can put 4 letters. Then after putting 4 letters, after putting 4 letter in the third position, in the fourth position any of the remaining 3 letters I can put. After that, for the fifth position, either of the remaining 2 letters I can put. In the last position there will be only one letter I can put here, right? So 6, 5, 4, 3, 2, 1. Okay, so now this way I can fill this fill this queue of this letter. This way I can fill this. So how many ways I can put one number in the first position? 6 ways. After putting one number, how many ways I can put the one letter in the second position? In 5 ways. Then 4, then 3, then 2, then 1. Now we'll use principle of counting. To find the total number. So here, so the number of choices of 6 position are as follows. So number of choices of 6 position are as follows. So total number of permutation will be, total number of arrangement will be, 6 into 5 into 4 into 3 into 2 into 1. That we call 6 factorial. So 6 factorial is equal to 720. So number of, this is my total event. I'm using the principle of counting here. The total event is, we have to find total number of arrangement. How we can arrange? First, for that total event, how many ways I'm placing one number in the first position. This is my E1, this is my E2, placing one number in the second position, placing one number in the third position. This is my event 3, event 4, event 5, and event 6. How many ways I can perform event 1? 6 ways I can perform event 1. After that, I'm going to event 2. How many ways I can perform event 2? In 5 ways I can perform event 2. How many ways I can perform event 3? In 4 ways I can perform event 3. How many ways I can perform event 4? In 3 ways. How many ways I can perform event 5? In 2 ways. And lastly, how many ways I can perform event 6? That is 1 way. So total number of ways, total number of permutation. So the total number of arrangement will be 6 into 5 into 4 into 3 into 2 into 1. That is nothing but factorial 6. So factorial 6 is equal to 720. So that is the answer. This is the way how we can use the principle of counting to find permutation, to find arrangement. Let me give you one another example here. So if I give you one another example, try to solve this one. You can pause the video and you can check. So if I give, suppose we have 3 numbers. We have 3 different numbers, 1, 2, 3. Okay, so I'm giving you 3 different digits, that is 1, 2, 3. Now how many different numbers you can make with this 3 digit? How many different numbers we can make with this 3 digit? Okay, now again this is a permutation. We have to find total number of arrangement of these 3 digits, right? We have to find total number of arrangement of these 3 digits. Now how we can do? So here, like we have 3 position, 1, 2, 3 position, right? So how many ways I can put one number? Either I can put 1 or 2 or 3 in the first position. So 3 ways I can place one number here. After putting one number, then there will be 2 numbers to put in the second position. After putting one number, then I can put only one number in the last position. So total number of ways will be 3 into, if I use principle of counting, 3 into 2 into 1, that is equal to 6. Now you can visualize this problem also with the tree. So how we can visualize this problem with the tree? Suppose we have 3 positions, right? We have 3 positions. So we have 3 positions, right? So 3 position will visualize. Let's just take. So in the first position, I can either put 1, 2, 3, right? After putting 1, in the second position, I can put either 2 or 3. After putting 3 in the third position, I can put 3 exactly. If I put 3 in the first position, I can put like 2 in the third position. So one number can be like 1, 2, 3 and 1, 3, 2. Similarly, if I put 2 in the first position, I can put either 1 or 3 in the second position. After putting 1 in the second position and 2 in the first position, I can only put 3 in the third position. Again, 2 in the first position, 3 in the second. Then I can put 2 in the last position. So then another number will be 2, 1, 3, 2, 3, 1. And lastly, if you use the same logic, so you can put like after putting 3 in the first position, then I can put 2 in the second position or 1 in the second position. If I put 2 in the second and 3 in the first, then in the last position I can put 1. And if I put 3 in the first and 1 in the second, so I can put 2 in the last position. So arrangement will be 3, 2, 1 and 3, 1, 2. See, we have here, as you can see, we have 6 different 1, 2, 3, 4, 5, 6 different arrangement. You can visualize the same problem with the tree also. We are having the same number. We have how many arrangements are there? So we have, this is one permutation 2, total number of permutation is, total number of arrangement is here 6. So that is the understanding of permutation. So hope you like it. So see you in the next video. Thank you.